All right. Good evening, everyone. I'm Michaela, and I'm the program coordinator for the Pemberton Library. Thank you all for joining us this evening for a beginner's guide to flood risk in Pemberton with Veronica Woodruff. Tonight's event is brought to you as a partnership between the Pemberton and District Public Library and the 1 Mile Lake Nature Center. I'd like to extend my thanks to Veronica for hosting tonight and for sharing her passion and knowledge with us. We're honored to be bringing tonight's event to you located on the unceded territory of the Lilwat and Stratliam Nations. If you're from another area in the province, feel free to say hi and where you're from in the chat box located at the bottom of your screen. Before I hand you over to Veronica, I just need to share some housekeeping information with you. Tonight's event is being recorded. For that reason, all microphones and cameras have been turned off, and if you could keep them turned off for the duration of the presentation, that would be great. If you have any questions throughout, you can put them in the chat box or the Q&A box at the bottom of your screen, and we'll have a question and answer period at the end, and I will relay those questions to Veronica. We're just going to do a little poll here before I hand you over to her. It should show up. There we go. If you wouldn't mind just taking a look at that. And then I think that's it. And I will hand you over to Veronica.
Thanks. Yeah, once you've voted, you can just minimize that poll. I'm going to do a little intro and then we will check on the results. So yeah, I'm coming to you on behalf of Stewardship Pemberton Society, and we're going to talk about flood risk tonight. I have jammed a whole lot of information in here because there's so many interesting new things to talk about with flood risk in Pemberton. So it'll be a bit like drinking from a fire hose. So at any time, capture your thoughts in the chat. I can't see the chat while I'm talking, but after we can have a bit more discussion if anybody wants. So yeah. Sorry, it always takes a minute when we have been waiting. And yeah, I would like to acknowledge that I'm here talking to you on the traditional territory of Lilwat Nation. And everything I'm going to talk about tonight is within the traditional territory of the nation. And tonight, if you've come to any of my other presentations, the context of my intro tonight is as a fish and wildlife technician and a environmental consultant. I did a diploma in restoration of natural systems, and I've worked as a field technician and a project manager on a variety of highly technical hydrology programs, invertebrates, water quality, and a whole range of fish and wildlife assessment and inventory projects all around the province. So it's from that experience that I'm going to be talking to you tonight. We have so many fascinating things in Pemberton and in the watershed that certainly fascinate me, that I'm anxious to introduce you to. I do like reading technical reports, and there's certainly quite a few of them on this new and increasing flood risk that we have in Pemberton. So I'm also a co-founder of Stewardship Pemberton, a society that we started in 2006, and we built the 1 Mile Lake Nature Center in 2011. And our mission is to connect community to nature. And this is one of the ways we do that is by doing talks like this. So this is a map of the Lilwat River watershed. So this light blue, can you see my cursor? Michaela, maybe give me a thumbs up. The light blue Lilwat River up at Silt Lake, and it starts at Lilwat Lake. And then you can see there's sub-basins outlined all along here. So North and South Creek, they aren't colored. This green is Meager. And then a watershed boundaries in Whistler. Alta Lake drains to the north towards Lilwat River. And of course, the Birkenhead.
Veronica, sorry, I can't see your cursor.
Okay.
No. Oh, wait, now maybe I can. Move it around.
Can you see it now?
No, I don't see it.
If anyone has the trick, I know that there is a trick to this. Pop that in the chat and we can maybe get this sorted. Anyway, it's not that important.
Okay.
Okay, so the Lillooet Harrison watershed is cool because it's part of the Fraser River watershed. It's the smallest land base of all the subbasins in the Fraser, yet it contributes the second highest flow. So really important for Fraser River water quality, especially for salmon migrating through in the summer because of our glaciated landscapes. It keeps the Fraser River water cold. So tonight we are talking flood risk, and we're a bit stalled. And I moved here in 2001, and I was friends with people that had grown up in Pemberton. And they talked about floods, and they said, oh yeah, my parents keep a canoe to the side of the house because when the Lillooet meets the Ryan, you got to be prepared. And I was, oh yeah, that's interesting. And I didn't really have any concept of how to prepare for that. And so when 2003 came around, it was really fascinating to experience that really big flood. And so we spent the day, the Friday, driving around and checking out everywhere that we could get through. And then of course, all the bridges washed out that night. So this is a picture looking towards Mount Currie in the back. And this is showing Oxbow Lake by the outdoor school. And this Oxbow Lake is kind of a classic meandering river landscape that you would expect to see. So where the river had a really wide bend and then it became disconnected and it has this remnant lake. We don't see that in Pemberton. The Lillooet's pushed up against the North Valley, the Ryan's up against the south. And so we don't see this landscape that if the river wasn't confined would be more dynamic. So this is looking up towards Mount Meager. You can see the river is unconfined here. It's kind of moving all over from right to left of the valley. It's not confined by dikes. So I'm going to introduce some data from reports, but also some tools. This is real-time hydrometric data. So a lot of this talk, I'm going to be talking about discharge. So this is a measure of a river passing a set point. So the Water Survey of Canada has gauges all around the country. They've got two in Pemberton, one at the Forestry Bridge in the Lillooet and one close to town that measures the level. So picture a meter stick in the river, so you know what the level is, and then how fast the water is moving past that point, which is your discharge. So this discharge, this is a year we're looking at in June. I pulled this about a week ago. And so you can see last year we had a couple of big spikes in the fall. They got up to about 600 cubic meters per second. So I am going to talk about a little bit when we get further into the talk about these discharge measures. This is looking at the Water Survey Canada gauge from 1914 onward. And there is data available from prior to 1914, but the ones online starts at 1914. And you can see here the different flood events that have happened. And this one in the early 40s was at the time the biggest one on record, and it created catastrophic flooding throughout the South Coast. And that inspired the federal government to launch the Prairie Farm Rehabilitation Act, where they invested millions and millions of dollars in creating arable land. And so this was not only in Pemberton, but it was throughout the Fraser Valley as well. So some of the initiatives that they did then was to cut off 14 kilometers of meanders. So you can see that here in the yellow circles. They just basically straightened the river. And they built almost 40 kilometers of dikes to keep the rivers into the newly straightened channels. The longest of that cut was the Mackenzie Cut at 4.3 K. And then they also lowered Lillooet Lake by 2.5 meters by blowing out the narrows at Tenace Lake and removing about 470,000 cubic meters out of that. So a lot of investment to allow people to happily live in this valley without being affected by water. So here's just the picture from the Diking District office on the right. That's when the cut first happened. And then the one on the left there, that's a picture I took, I think around 2011. Okay, so here's a picture of the 1947 aerial photograph with the cadaster over top. So this is the boundary lines from today. This is the Arn Canal, not the railway, that blue line. But you can see, like at the Glen and where the lights are in town there, it's built right over top a side channel of the Lillooet River. The Lillooet came through. This is the Fraser-Erdel connector and created a big back eddy where 1 mile was, and then continued downstream to where it met with the Green. So this is why I used to live in the Glen, and my yard was completely sand, and then my neighbor across the street would dig a little bit down, and her yard was quite cobbly. So you can see that there was all sorts of arms of the river that went right through town. So the next flood on record was 84. Thanks, the Diking District posted those pictures, and Michelle Beck shared those to the forum, which was really cool to see the 84 flood. And so the infrastructure that was in place at that time is not the same infrastructure that's there today. Certainly many upgrades took place from the 84 flood. And the 91 flood was quite a large one. It didn't have the same kind of impact in Pemberton as the 84 flood, though it did really impact Whistler. That bridge between Whistler and Blackcomb was washed away during that flood. And then we had the flood of 2003. That's the largest return on record. And this is just I've got a couple of photos from that flood. This is the Rutherford Bridge. And next time you're driving to Whistler, just really have a look. You can see at the bottom of the picture here, there's the train bridge that's basically come off its footings. And when you look and see how far away the train bridge is from the actual channel, it's really astounding how high the water actually got to. And of course, this is Nairn Falls. These are people standing from up on the platform. And this is what it looked like in 2003. The river was high enough to be depositing logs up onto the platform. And this is looking at, if you stand below the platform there, it hits a wall. And it's basically right down to bedrock. There's no trees or moss or anything. And this is why, because the power of floods in like 2003 is what scrapes that whole bedrock to nothing. And so floods like this are a result of these atmospheric rivers. So these Pineapple Express storms that come in, they come in really warm and laden with precip. So really high precip levels with really high freezing levels. And this is the kind of storm that we're expecting to continue to increase. And what happens is, especially if these storms come in in early winter or around the fall, where we've had some snowfall, and the snowpack isn't consolidated enough to be able to withstand the rain. If you get a ton of rain in the middle of winter, the snowpack acts as like a pillow. It can just suck up all that water. If the snowpack isn't consolidated enough, all that snow melts at once. So even in the case of 2003, that was a 300 millimeter storm. And in addition to melting snowfall. So all of the snow that gets melted all becomes part of the runoff. And this, again, is the kind of storm that we can really expect with both greater intensity and frequency. There are reports from the International Panel on Climate Change that says with high confidence that this is exactly what we're going to be seeing. And I like how the IPCC basically qualifies every statement they make, like, okay, well, this is going to happen, and in brackets, we think this with high confidence or low confidence. And I think that this is something we could consider how we speak day to day about certain controversial topics. This is another tool that I really like. This is the Clever model. So it's a 10-day model out of the BC River Forecast Center. And this is just a personal tool that you can go online and check this out. If there was ever a flood forecast or even a high stream flow advisory, you would get notices of that from your local government. but I like to be in the know. So if I see a rainfall forecast 5 days out, I could go and check these models to see what is expected. And you can see here, the legend is there on the left. And so in the Fraser Plateau and the Thompson Plateau, they've got a couple of, 10-year flows, expected high flows. And this is similar to the coffee model. This is a model that operates in the fall when rainfall is forecast. And so it really gives you an idea of the prediction on how intense an event might be. So this is a map of Pemberton. You can see the two Pemberton gauges, the one right near town and the one up at the Forestry Bridge. And you click on that during when rainfall is forecasted, and it will tell you what the anticipated flood return level is going to be. Okay. I'm really going to focus on floods, but Mount Meager landslide of 2010 is really a big part of why our flood risk is increasing so much. So these are before and after pictures. Oh, you can't see my cursor. This, you can see in the top left-hand picture, the secondary peak lower down, that is what collapsed. That whole secondary peak and surrounding rock came down and deposited 50 million cubic meters into the valley below. And the top right, you can see that secondary peak is no longer. And then if you look at the bottom left, you can see the secondary peak in the distance. And then the bottom right, you can see that secondary peak and the whole slope has sheared away. So this is a before picture of Mount Meager. So you can see Meager Creek coming in. You can tell that there is disturbance there. This is the most active volcano in Canada. It is still considered dormant, but the last time it erupted, it was in a glacial landscape. So really fast cooling, and it's been described as a mountain made of ball bearings, and it has experienced a whole range of slides in addition to the Capricorn Creek slide in 2010 over the last millennia. So, and so you can see from this picture, there's quite a disturbance even before 2010. So this is the deposition after 2010, and you can see how it really just blanketed the whole valley with that debris. And it is because they're so cool, I'll show you a couple before and after pictures. You can see the secondary peak at the top of the slope here. It's a big, huge convex roll. There's water flowing underneath that. These are all pictures from this report. And here's the after. So it's become this concave slope. There's before, and here's that after picture again. And that's for scale as a helicopter there. The slide was so big that it registered a seismic trace 2,800 kilometers away in California and Alaska. And yeah, so it's the largest landslide in Canada that's ever occurred, larger than the Hope slide and the Frank slide. And it's the largest landslide that has occurred in the world since 1947. So a really substantial event. This is the water that dammed up behind the Capricorn Creek slide at Meager Creek. So this is Meager Creek looking downstream to the slide debris. And this is what it looks like now. So you can see the amount of material that is still sitting there 10 years later, just continually mobilizing downstream. You can see how narrow Meager Creek is now. But yeah, there's a ton of material still sitting up there. And just for last comparison, this is the before and after. And we do have ongoing risk of another landslide on Mount Meager. And it has gained international attention, both from researchers and from media. This is a picture of the amount of glacier recession. Those unstable slopes become unsupported as the glacier recedes. And so this is where this risk is coming from. Number 2 here in the center, that's the Capricorn slide. But up above that, where it says the letter A, and you can see that large unstable slope boundary, the black and white boundary. Sorry, my cursor's not working. That is a huge area of instability that's moving quite actively, up to 10 centimeters a month. That's being monitored in real time. So we do have a range of instabilities that are of concern at Mount Meager. Okay, so Lillooet River floodplain mapping. This report was really well done. in 2018. The previous floodplain mapping had been done quite sometime earlier. And this was really well scoped. So the consultant, NHC, they had an appropriate budget, and they did really great work to determine what our current flood risk after the slide was. So I just want you to concentrate on the yellow here. I'm going to talk a lot about flood returns. And I just wanted to explain what I meant by say a 1 in 2 year flood or a 1 in 200 year flood. And it's not that we're going to get that return every other year. It's really just a probability. So the percent chance that we're going to see a 1 in 5 year flood is a 20% chance in any given year. So the 200-year flood has a 0.5% chance of occurring in any given year. So I am going to talk a little bit about the 1 in 200-year return. And the reason that is important is because all of our flood, our dikes and all of our flood control properties are supposed to be constructed to the 1 to 200-year return. And prior to the landslide, that's what they were. And so this is just from the Floodwise website, a really great website from the Lower Mainland that talks about flooding from the Fraser. They have a really great website. Check it out if you're interested in this kind of stuff. But the risk here is from water coming in from behind the dike. So internal flow. So it's something like we see at the Arn Canal. And if you're at the peaks in 2003, you know what that looks like in terms of flooding. Of course, we have dike overtopping, dike breach, what you saw in Hurricane Katrina when the whole dike just fell apart. And in Pemberton too, we have a lot of challenges with seep. So dike, that hydrostatic pressure of the water underneath the dike. Okay, only pay attention to these two columns. This is from the new updated floodplain mapping. So this is showing what our return periods are and the estimated of cubic meters per second. So our discharge at that time. And so I want to highlight this one. The discharge in the 2003 flood was just about 1,500 cubic meters. At the time, the 2003 flood was considered to be a 1 in 200-year flood, so a really big event. According to the new floodplain mapping, the 2003 flood doesn't even meet the criteria for a 1 in 50-year return. And so really concerning. Again, so a 1 in 50-year flood has a 2% chance of occurring in any given year, rather than the 0.5% chance that a 1 in 200 does. And so what are we doing with this increased flood risk? The reason the flood risk is increasing so much is because of that Mount Meager slide debris. And originally, the original estimates of the sediment moving from the upper valley into the populated areas of the river was originally 30 to 40,000 cubic meters a year. Since the slide, that estimate has gone up closer to 200,000 cubic meters a year is being deposited throughout the valley. So you can imagine when we're getting this movement of sediment, it really reduces the efficacy of your dike infrastructure. As part of the report, and I do have a kind of a PDF that goes with this, that has links to all these reports if you ever wanted to follow up on them. But that NHC, the 2018 report, had this geomorphic atlas that really detailed in very short reaches what was happening and where the material was moving, and how they were really quantified how they thought the effects of the slide material was affecting the river. So for example, here in the picture on the top left, they were noting areas that saw riparian die-off because of heightened water levels, and also the different types of bar formation. This is an extension of the 2018 report. This was work done in 2019 to develop a sediment management plan to deal with all this material. And they talk about the slug. So you can imagine that all this slide debris came down and it's slowly being mobilized annually by high water, by freshet, and that slug of material is slowly moving into the lower watershed. So in 2017, the slug had reached approximately 14 kilometers upstream of the forestry bridge. The slug represents about 7.5 million cubic meters of material of the 50 million that was deposited. So it's a really large mobile portion of the slide debris that is now moving towards these populated areas through town. And when you look at this updated report, you see the really high impacted areas are between the forestry bridge right now and the confluence of the Ryan Miller. That section of river is really seeing an influx of the smaller sediments that are ahead of this big slug that's made up of, a bit more coarser material like gravels versus sand. The report states that this is supposed to continue for the next several decades. They are very vague in their terminology about when it can be expected to really deposit through town and then how long that could occur for. However, they are firm in that the sediment loading is at least five-fold what it used to be. And in order to deal with it, we really need to start looking at removals in the range of around 210 to 260,000 cubic meters a year, which may be necessary to reduce our flood risk. So back to this one, I just want to drive, we were looking at the 1 in 50 flood that was similar to the 2003 flow. And I just want to highlight this 1 in 5 year flow. Again, a 1 in 5 year flow has a 20% chance of occurring in any given year. And this is our water survey gauge. In 2016, we had a 1 in 5 year event according to the new updated floodplain mapping. And if you live near Northern Farm or in areas of the Upper Valley, you know that 2016 caused quite a bit of flooding. When you look on the return period from the Lillooet River gauge, you see that it doesn't actually, it's not way up there by 2003, yet it did cause quite a bit of flooding. This is my house. I live by the highway bridge, looking at the dike there along the Valley Loop Trail. And yeah, the water came really close to overtopping in 2016. And so a really big cause for concern. So I'm going to go through, so if you want to know how this affects you specifically in Pemberton, there's really, really great floodplain mapping that I'd like to go through very quickly that documents the 50, the 100, and the 200 year returns. So the 1 in 50, 1 in 100, and 1 in 200 year flood return. So the following 3 maps, this is the legend, and you can see here the flood depths in yellow from 0 to 5.5 meters, so like up to your knee depth. Most houses are dry, walking and moving in water, driving is potentially dangerous, basements, underground parking may be flooded, potentially causing evacuation. So kind of bad, but not terrible. And then we get into the next range, which is the light green. And you can see the last sentence there. Electricity's failed, vehicles are commonly carried off roadways. So we go from kind of bad to worse very, very quickly. And anything above that 1 meter is just all bad. So this is the, I decided to pull the map. You can see on the right-hand side here, I've pulled map number 3 in the top, the little main legend there. So you can pull any of these more zoomed in maps to look if you're in the Upper Valley or if you're down towards the industrial park. You can really get a good look on what you can expect to see in a 1 in 50 year return. So again, those yellows are about knee deep. Green is about as deep that could carry a car off a road. This is the this is the 1 in 100 year, and they really have a great gauge on where the vulnerable points are going to be, which dikes are going to overtop first, and how the flooding is going to happen. So this is what the floodplain mapping does. And then finally, the 1 in 200 year flow. And you can see some of these really dark areas. You're looking at a 2 to 5 meter depth. So yeah, I really recommend going on to the SLRD or the Diking District website. They have these maps available in the floodplain mapping report from 2018. And so who is doing what with this risk? Well, the government of Canada is responsible for multiple departments of public safety and, of course, Indigenous services, infrastructure, climate change, National Research Council, Natural Resources Canada. They have all of these levels of governments that are responsible for, in some way, emergency management. And of course, that includes public safety, so RCMP, if it ever got to armed forces being deployed. Of course, their monitoring equipment through Water Survey of Canada and all the meteorological monitoring, and of course, Agriculture Canada. And then BC, responsible for emergency management. They've got the Water Sustainability Act, so environment, climate change. They deal with authorizing local governments to do work through the Local Government Act, dike maintenance, and then all this monitoring assessment, some of the tools that I've highlighted already. And they administer, both of these higher levels of government administer funding programs. And then we get down to our local government. The Pemberton Valley Diking District is an autonomous organization, government organization, that is in charge of flood protection. So they are authorized under a letters patent through the provincial government. And then we've got Lillooet Nation, Village of Pemberton, and the Squamish-Lillooet Regional District. And they all have planning and infrastructure management, their bylaws for things like flood protection, your flood construction levels, your development permit areas. And if there's ever a cross-boundary emergency, then any emergency gets managed through EMBC. So it goes up a level of government. So with this ongoing risk and this heightened risk from the landslide debris being deposited, the 4 levels of local government, so PVDD, Lillooet Nation, SLRD, and the Village of Pemberton, have formed the Pemberton Valley Emergency Management Committee, and they have been working, they have been meeting often and working to come up with strategies to deal with this. So both from top down, bottom up, they are working proactively with the higher levels of government. There are projects that aren't currently being funded that desperately need funding, and so working on those relationships. They just, this report was just completed. You can see it from June last year. And some of the core flood mitigation plans are outlined in this plan are dike upgrades and construction, gravel removals, infrastructure improvements, land use planning and emergency preparation, which something like this is part of, and of course, additional hydraulic modeling. That's really part of the monitoring. This report includes a return on investment. And for infrastructure, you can imagine building a dike is incredibly expensive. And even raising a dike is incredibly expensive. And you're constrained by a whole range of legislation or property lines. And so it's really challenging to raise dikes. Also, the gravel removals that we have been doing as a way to mitigate the flood risk is really just keeping up with the risk at the time. So for example, last year, almost 60,000 cubic meters was removed through the populated area in the Lillooet River, so between Ryan and Green River. And that 98% of that material had been redeposited by September of that year. So that project cost millions of dollars and gives us a 6-month window. And so similarly, the gravel removal just was completed in the last 3 weeks, and they removed another 60,000 cubic meters of material. And again, the 2019 report suggests that we have to be looking at removing 210 to 260,000 cubic meters to really make any kind of dent. So yeah, this report here, I don't know if I said this, but it does talk about infrastructure upgrades in the $50 to $60 million range for improvements that don't give a huge return on investment. So not a great selling point for trying to garner that much funding. So we did a research project in the fall about understanding people's preparedness for emergencies. And I'm just going to show a couple slides here. I'm really trying to be conscious of the time. So this just shows people haven't prepared grab and go kits or 72-hour emergency kits. Although people have signed up for emergency notifications, both the SLRD and Pemberton have their own alerts. I know for myself, I've signed up for both, even though I live in the SLRD. I recommend if you haven't signed up for these already, that you do so. I can provide links to how to do that in the chat when we're done. And when we asked a bunch of questions about emergency evacuation, and I thought that these were some of the interesting answers to highlight. Oops, sorry. That most people would evacuate immediately if required to do so, but up to 20% would need assistance, so in some form. Also, 50% have pets and 4% have livestock that will require evacuation. So if you're wondering why I'm telling you all this instead of an official government employee, I really feel like I am really well aligned with the BC's approach to emergency management. So here it says like it's an all of society approach. I find this topic really fascinating, and I have this platform through Stewardship Pemberton, and so this is one of the reasons that I want to do this. I feel like it's my personal responsibility to be prepared and let my friends and community know that they should also consider how they can become prepared. And I know that there are going to be future government officials that are going to take on this role in the near term. And that has been a priority that's come out of some of those planning documents. This is a really good, I thought I'd put this one in there for any of the agricultural producers up the valley. The Ministry of Ag in BC has a really good emergency preparedness tips. And I went through this and I hadn't actually thought about many of them, about storing potential toxic materials, whether it's fuels, and being prepared to deal with those things in the event of a flood. When you have forecasts for high water, you don't want to start thinking about, oh yeah, well, I've got a shed and it's got a bunch of paint and some fuel. Like those are probably the lowest priority if you've got 20 head of cattle sitting in your yard. So, so yeah, it's really for me, my motivation here is just to talk about preparedness. It appears from all the data that we are looking to when we're going to flood rather than if we're going to flood. And so we all have this level of responsibility to know our risk and become personally prepared. And I think under that personally prepared, it also is community preparedness and neighborhood preparedness. And so it's not just about what I need to do personally, but just how can I help my neighbors become more prepared? There's a couple of ways to get engaged. We have two research projects. One is being initiated that should kick off in the next couple of weeks. It's a researcher from Vietnam who's working out of SFU, and she is researching effectiveness of messaging. And so she's a little firecracker, and she's been really fun to work with. She's working with Stewardship Pemberton as her community partner. So look for her research to come along. And another big project that is being undertaken, led by Liwat Nation, is some restoration in the slide debris and trying to stabilize some of that mobile material so that we can reduce the amount of time that this risk is going to continue for. And so there's some precedent around large scale restorations. You see it in mining or in reservoir restoration, and using some of those techniques to really target some areas that could use some treatments to shore up some of that mobile material, and also recreate habitat values. Coho and Chinook spawn right up to Meager Creek and beyond up to Keyhole Falls, and important area for bull trout, and of course wolverine and moose and grizzly bears and all the rest. So to recreate some of the habitat value in the watershed. And again, I'm not government, but I'm always happy to chat about this fascinating subject. But here's some people that you can talk to if you did have some more concerns. Some official people. So the SLRD has been working really hard. Obviously, they have quite a large area of responsibility because they're not only Area C, but throughout the whole regional district. And the emergency program coordinator, Sarah Taus, out of the village of Pemberton, and Kevin Clark from the Pemberton Valley Diking District. And thank you. That's all I have. I was going to, there's a really great animation that you can watch that takes those floodplain maps and animates them, and I'll throw the link in the chat. And I thought I would end there, but I feel like I've bombarded you with negative information, so I really want to leave on a positive note here. I think understanding what the risks are can feel overwhelming, but at the same time, not knowing the risks, I think puts you in a worse position in the long run. So I really appreciate you listening to me. If you have any questions, feel free to turn on your camera and we can have a chat. All right.
There were no questions while you were talking. I'm just gonna stop recording now, so just in case anybody is uncomfortable putting their voice on recording. So hold on one second here.
Okay, Bruce, is Diking District gravel removal program able to keep up? No, is the short term, not